Welcome to the debate. Imagine a near future where you can no longer write a coherent essay, solve a complex problem, or even remember basic facts without first consulting an algorithm. Are we offloading so much of our thinking to artificial intelligence that our minds are, well, fundamentally atrophying? We really want to hear where you stand on this critical issue today, so please leave a comment with your thoughts as we unpack the evidence. The central question we are tackling, drawn directly from our source material, is this. Is the rapid integration of AI into our daily lives causing widespread cognitive laziness and skill degradation, or is it a revolutionary tool for cognitive augmentation that frees human mental capacity for higher-order thinking? My stance is that AI is a powerful cognitive extender that reduces extraneous mental load and elevates our capacity for complex problem solving.
Is deep metacognitive laziness and cognitive debt, which fundamentally weakens our intrinsic critical thinking and memory retention.
I think to really grasp what's happening here, we have to look at how human memory actually works. The current wave of AI isn't just about, automating factory floors, it's about profound cognitive augmentation. John Sweller's cognitive load theory is a perfect lens for this.
Right, Sweller's work is foundational. But for anyone who hasn't read up on cognitive psychology lately, how are you applying his specific framework to AI?
Right, so Sweller points out that our working memory, the part of the brain actively processing information right now, is strictly limited. Whenever we engage in a task, we deal with different types of load. There is intrinsic load, which is just the inherent difficulty of the task itself. Then there's extraneous load, which is the frustrating, inefficient presentation or retrieval of information. Think about trying to write a complex report while simultaneously having to format the document, search for basic definitions, and organize a messy dataset. All that extra friction is extraneous load.
It takes up bandwidth.
Exactly. By offloading those elements to an AI, we aren't becoming lazy. We are strategically freeing up our limited mental resources for what Sweller calls germane load. That is the deep, schema-building effort where true learning, synthesis, and innovation actually happen. We can also look at the extended mind hypothesis proposed by philosophers Clark and Chalmers, which frames digital tools as external cognitive prostheses. AI is acting as an extension of our own minds.
Like a physical tool, but for the brain.
Precisely. Think about the calculator. Decades ago, critics absolutely panicked, claiming the pocket calculator would kill human mathematics. It didn't. Instead, it eliminated the drudgery of manual arithmetic and allowed us to build billion-dollar industries in engineering, physics, and computer science. AI is doing the exact same thing today for language, logic, and reasoning. It isn't replacing the thinker. It's an evolutionary step in human-computer interaction.
Look, the calculator history is fascinating, yeah, but I think the analogy fails to capture the deeply generative nature of modern AI. We aren't just offloading arithmetic anymore. We are offloading the very mechanics of human thought, and we are paying a steep price for it. The academic literature refers to this as digital amnesia and cognitive debt.
Cognitive debt being the idea that we're borrowing performance from the machine today at the expense of our own future ability?
Exactly. It's the measurable decline in mental performance that results from over-relying on external tools. To see this in action, we only need to look at the recent MIT Media Lab study, Your Brain on ChatGPT. Researchers hooked participants up to EEG machines to monitor their brainwaves. They asked one group to write an essay entirely on their own, and another group to use ChatGPT. The results were startling. The users writing without AI demonstrated significantly stronger alpha band connectivity and occipital to frontal information flow.
Okay, occipital to frontal flow is a bit of a mouthful. For those of us who aren't neuroscientists, what does that actually look like in everyday terms?
Think of it like a massive high-speed highway in your brain, communicating between your visual and sensory processing centers, the occipital lobe, and your complex problem-solving center, the frontal lobe. In neuroscience, that specific highway lighting up indicates deep internal brainstorming, semantic retrieval, and genuine cognitive engagement. You are actively pulling memories, testing concepts, and synthesizing ideas.
And the group using ChatGPT?
In stark contrast, the individuals using AI essentially offloaded that entire creative burden. Their brains showed measurably lower cognitive engagement. That septal to frontal highway was barely seeing any traffic. They weren't elevated to higher order thinking. They simply stopped thinking as hard. I mean, you know that awful friction you feel when you've been staring at a blinking cursor for 20 minutes, trying to figure out how to start a paragraph?
Oh, absolutely. It's the most frustrating art of the writing process.
We hate that feeling, but that friction, the strain of struggling to synthesize information, is where the actual thinking is happening. It's a feature of human intelligence, not a bug. When we use AI to remove that blinking cursor, we remove the cognitive workout. We induce widespread metacognitive laziness.
That brings us to a really crucial arena, which is education and intellectual development. If the friction is the workout, what happens when students bypass it entirely?
It's a crisis in the academic environment. Author Cal Newport uses a brilliant analogy here. He points out that using AI to minimize cognitive strain in a learning environment is like using an electric scooter to make the marches easier in military boot camp.
That is a fantastic analogy. If you're at boot camp and the drill sergeant says march 10 miles with a heavy pack and you pull out a scooter, you've missed the entire point of the exercise.
Right. Yes, you achieve the short-term goal of getting to the finish line faster, but you entirely defeat the long-term conditioning purpose of the march. We are seeing this across educational institutions right now. Dan Levy, a senior lecturer at Harvard, emphasizes that students are increasingly confusing the act of producing an output with actual learning. When a student uses generative AI to instantly draft an essay or solve a complex coding problem, they are bypassing the memory synthesis that is absolutely crucial for knowledge transfer.
Because they haven't built the internal scaffolding.
Exactly. They are skipping the intellectual effort required to internalize key concepts. This metacognitive laziness means they aren't building the neural pathways necessary to apply that knowledge in novel future situations. They get the output, a perfectly formatted essay or a functioning piece of code, but they lose the education.
I see why you think that, but let me give you a different perspective. Acknowledging that bypassing struggle is a risk does not mean the tool itself is inherently detrimental to learning. If the goal is just to build raw muscle, yes, the scooter ruins the boot camp. But what if the goal of the modern knowledge worker isn't just to march, but to design the map?
You're saying the nature of what we need to learn has changed?
Exactly. When integrated correctly, AI actually optimizes the learning process. Educational research demonstrates that AI-driven adaptive learning environments can reduce mental fatigue and significantly improve knowledge acquisition. The issue isn't the tool, it's the pedagogical approach. We shouldn't frame AI as a replacement for human thinking. Instead, we should look at Chris Didi's concept of Athena's owl.
I'm familiar with Didi's work, but break down the Athena analogy for us.
In Greek mythology, the goddess of wisdom, Athena, is accompanied by an owl that sits on her shoulder. AI is that owl. It is an entity that sits on your shoulder, absorbing massive amounts of data, seeing in the dark, and making calculative predictions. It handles the heavy computational lifting so that the human, Athena, can focus on wisdom. Didi makes a crucial distinction here. AI allows us to focus on doing better things, not just doing things better.
But how does that play out for a student who still needs to learn the basics?
Well, when a student isn't bogged down by the mechanics of formatting or manually synthesizing preliminary research, that extraneous load we talked about earlier, they can engage in higher-level critique. They can question the premises of an argument rather than just struggling to write the sentences down. The struggle shouldn't be about finding the data. It should be about what the data means.
That's an appealing vision for education. But have you considered what happens when this dynamic scales up into the workplace? We aren't just talking about students learning how to write essays. We are talking about professional labor. And here, the alarm bells are ringing around task encroachment.
Task encroachment meaning AI taking over things we previously thought only humans could do?
Precisely. Historically, automation replaced mechanical, repetitive, physical tasks. The tractor replaced the plow. But AI is no longer just doing mechanical work. It is rapidly encroaching on cognitive work. This leads directly to professional de-skilling. Take the graphic design industry as a practical example. A graphic designer spends years mastering the artisan skills of illustration, color theory, spacing, and typography. But now they're increasingly relegated to merely editing AI-generated churn. They become a manager of outputs rather than an active creator.
Reader of algorithmic mediocrity.
And as they spend less time generating original work from a blank canvas, their core skills decay. Furthermore, this dynamic breeds automation bias, because our own evaluative musculature has atrophied from lack of use. We begin to implicitly trust the machine. We accept plausible but fundamentally flawed AI outputs because we've lost the sharp critical edge required to rigorously interrogate them. The graphic designer stops noticing that the kerning is off or the color palette is derivative. We are degrading the very nature of human expertise.
That's an interesting point, though. I would frame it differently. When we examine the workplace impact through the task automation augmentation matrix, a much more optimistic reality emerges.
Since we can't project a visual matrix for the audience, what are the actual axes we're looking at here?
Imagine a simple graph. On one axis, you have the time a task consumes. On the other axis, you have the mental effort it requires. Where does de-skilling actually occur? It primarily happens in high-time, low-effort tasks. Think massive data entry or basic administrative sorting. It also happens in low-time, high-effort tasks that involve intense but narrow computation. Eliminating those specific quadrants does not destroy human expertise. It liberates the workforce to transition entirely into strategic and creative roles.
But you're assuming everyone can just seamlessly transition into high-level strategy once the basics are automated.
Well, let's look at performance distribution. In almost any industry, the top 1% of the workforce already performs at elite levels. They have refined their workflows, they synthesize information beautifully, and they innovate. What AI does is provide the cognitive scaffolding for the rest of the workforce to achieve that top-tier performance. It raises the baseline of human capability. It helps the average worker communicate as clearly, analyze as deeply, and produce as efficiently as the elite workers already do. That isn't degrading labor, that is a massive, systemic upgrade to human productivity and potential.
I'm sorry, but I just don't buy that. Let me tell you why. You are assuming that the AI is providing a ladder to elevated original thought. But the systemic reality is that relying on algorithmic scaffolding threatens our unique human cognition across society. AI models are, at their core, sophisticated prediction engines.
Right, they are predicting the next token, the next word, or the next pixel based on their training data.
Exactly. And because of this, they heavily favor familiar, safe, and statistically average outputs. When an entire workforce or an entire society relies on these engines, it inevitably leads to a homogenization of thought. We build massive, automated echo chambers. We even risk what data scientists call model collapse.
Model collapse is a fascinating concept. Can you unpack that a bit?
Imagine making a photocopy of a document. It looks pretty good. Now make a photocopy of the photocopy. Do that 100 times, and eventually you just have a blurry, illegible gray page. Model collapse happens when AI systems begin training on data generated by other AI systems. As the internet floods with AI-generated text and imagery, the next generation of algorithms train on that synthetic data. The data pool becomes incredibly repetitive, shallow, and stripped of the eccentricities of human originality.
So the AI essentially poisons its own well.
Exactly. And because we are outsourcing our ideation to this statistical average, we are losing our tolerance for the messy, frustrating process of true innovation. We are losing the ability to patiently endure the confusion, the cognitive dissonance, and the dead ends that are the absolute prerequisites for genuine aha moments. We are trading human ingenuity for synthetic mediocrity, and we're too comfortable to realize it's happening.
I'm not convinced by that line of reasoning because it fundamentally misunderstands the biological uniqueness of human cognition. We are not just calculating machines, and human thought is not just statistical probability. As Harvard researcher Tina Grotzer points out, the human mind is better than Bayesian.
Bayesian, referring to statistical probability and predicting outcomes based on prior data.
Right. An AI operates on pure statistical covariation. It looks at a billion examples and guesses what comes next. But the embodied human mind operates in a physical, emotional, and social context. We use what neuroscientist Antonio Damasio calls somatic markers.
Somatic markers. Like a physical intuition?
Exactly.
Have you ever just had a gut feeling that a project was going off the rails, even if all the spreadsheets said it was fine? Physical sensations and emotional intuitions allow us to make incredibly quick leaps that defy pure statistics. Humans can detect critical exceptions to the rules. We can reason analogically across entirely unrelated domains, like comparing a military boot camp to an educational curriculum, which we literally just did. AI cannot do this. Because machines calculate without human experience, they cannot generate true meaning.
They can mimic meaning based on patterns, but they don't actually understand the context.
Correct. They can structure the data, but the meaning-making, the contextual evaluation, and the truly disruptive innovations will always remain safely within the human domain. AI reflects what is. Humans create what's next. We use the tool to clear the brush, but we still blaze the trail.
But blazing that trail requires a mind that hasn't been softened by convenience. When we allow an algorithm to do the heavy lifting of synthesizing information, we may think we are saving time for higher-order reflection, but in reality, we are failing to build the foundational knowledge required to reflect deeply in the first place. You cannot have higher-order thinking without the foundational blocks of memory and synthesis, which are forged only through cognitive effort. That is the core of the cognitive debt we are accumulating.
To summarize my position as we draw this analysis to a close, AI represents a necessary and extraordinary evolutionary step in human-computer interaction. It acts as Athena's owl, a highly capable cognitive partner. By stripping away extraneous mental load and handling the sheer volume of data processing required in the modern world, AI unlocks unprecedented levels of human creativity, efficiency, and problem-solving capability. It doesn't replace human thought, it removes the friction, allowing us to think bigger.
And my position remains that we are paying a dangerously steep price for this technological convenience. We are trading our foundational critical thinking, our memory retention, and our intellectual resilience for the sake of quick, frictionless answers. If we continue to let algorithms do our synthesizing and avoid the essential strain of the blinking cursor, we will incur a profound cognitive debt that leaves our minds ill-equipped to handle the novel, complex challenges that AI cannot solve.
Despite our different perspectives, I think we have found a critical point of convergence today. We both entirely agree that the passive, uncritical use of artificial intelligence poses a severe threat to human intellect. The blind acceptance of algorithmic output is genuinely dangerous.
Absolutely. The common ground here is the urgent necessity for what the literature calls AI literacy. This is the deliberate, intentional practice of using AI as a tool to expand our thinking, rather than as a crutch to replace it. It's the difference between looking at an AI output and asking, "What am I missing here?" instead of lazily asking, "What's the answer?"
Exactly. Maintaining our human agency in the digital era is incredibly complex. Finding the right balance between the undeniable convenience of these technologies and our own cognitive well-being isn't something that happens by accident. It requires continuous, mindful effort from all of us. There's so much more to explore in this material regarding the future of human cognition.
The challenge is entirely in our hands. It's up to each of us to ensure the owl stays on our shoulder and doesn't take over our minds.
We want to urge everyone listening to reflect on your own daily use of AI. Are you using it to elevate your thinking or to avoid the hard work of learning? Form your own conclusions. And please, remember to leave a comment with your thoughts on whether AI is making us fundamentally lazy, as we requested at the top of the show. Thank you for joining us for this intellectual exchange. Until next time.